In this video, we're going to discuss the concept of a greatest common factor and how to actually factor it. So let's start by talking about an example. So let's say we're given 27x cubed and 18x to the fourth, and we want to find out what factor do they share, and what is the biggest of those factors. Well, what we're going to do is we're going to start by breaking up each of our terms into its smallest prime factors. So for example, 27x cubed, you start with the 27. If you do a prime factorization on that, you're going to get 3 times 3 times 3. And x cubed, you'll have x times x times x. So notice that we're breaking down both the coefficient and the variable. Then for 18x to the fourth, when we factor that out, we're going to have 2 times 3 times 3, and x to the fourth, again, is x multiplied 4 times. Quick reminder, if you're perhaps trying to remember prime factorization, how does that work? For example, with 18, if I wanted to break it up into, let's say, 2 and 9, I could do that. 2 is a prime number, so I circle. 9, I can then break up more because it's a composite number, and it's equal 3 times 3. So 2 times 3 times 3, and that is my prime factorization. Now, you're going to notice that I have lined these up where the numbers that are shared are vertically aligned. So, for example, there was no 2 in the 27, so that spot is blank. But there are shared 3s in both. Okay, there's also shared x's, and I've circled each pair of things that are shared. And then I'm going to carry those down, and I can see that therefore my shared factors are 3, 3, x, x, and x. So my greatest common factor is what I get when I multiply all of those together, and that comes out to be 9x cubed. So that's what I could factor out of both of my given terms because it's the greatest common factor. Now let's try another one. What if we have three terms? 21x cubed, 9x squared, 15x. Well, the great news is it's the exact same setup. You're still going to completely factor each term. So for example, 21x cubed, you can write as 3 times 7 times x times x times x. 9x squared, you'll write as 3 times 3 times x times x. And 15x, you'll do 3 times 5 times x. Notice that for the coefficients, when I'm breaking them up, I am writing those factors in increasing order from smallest to largest. That way it is easier for me to line up the ones that match. Now you'll notice in this case, every single term has a factor of 3 and a factor of x. Therefore, when I bring those down, I can see that my greatest common factor had to be 3x. All right, what if I have something like 4x plus 12? How do I factor that? Well, in this case, we're going to find the greatest common factor of each individual term. Okay, so 4x and 12, we're going to break up 4x to be 2 times 2 times x. 12 we can break up as 2 times 2 times 3. Notice that we have 2's twice, so we can carry those down. Our GCF, our greatest common factor, is now 2 times 2, which is 4. Now that I know my GCF, I can go ahead and pull that GCF out. So what I'm going to do is I'm going to write each of my individual terms as my GCF times something else. All right, so 4x, I'm going to write as 4 times x. 12, I'm going to write as 4 times 3. Again, notice that 4 is that common number that I'm working with because that's the GCF we just found. Okay. Now, when I pull 4 out of both terms, what will be left? So this is called the reverse distribution property. So you'll notice when I took a 4 out of 4x and a 4 out of 4 times 3, I was left with x and 3. So I have 4 times x is 3. Again, 4 here is the GCF. Now, you generally want to check this. I understand you won't have time to do that for every problem, but especially as you're getting the hang of it, I highly recommend doing it. If you were to redistribute that number on the outside, do you get the correct answer? Well, 4 times x, there should be 4 there, 4 times x and 4 times 3 do give me 4x plus 12. So, check. Woo! Now, let's try another one. In this case, we're going to factor 8m cubed minus 12m squared n plus 20m n squared. So again, we need to find the GCF of all the terms. So we're going to break them up. 8m cubed can be written as 2 times 2 times 2 times m times m times m. And then you can repeat that for the other two terms, so 12m squared n and 20mn squared. And when you do that, you'll notice that the 2's are shared, another set of 2's are shared, and a set of m's are shared. So 2 times 2 times m is 4m, and that is going to be our GCF. So now we want to write out our polynomial where each term is now a product of 4m and something else. So in this case, 8m cubed, for example, is 4m times 2m squared. Now you might be asking, but how do I know what that other thing is, right? So when you're looking at how you've done your prime factorization, we have a 2, an m, and an m left over outside of what matched with the other terms. So that's 2mm or 2m squared. And that's where this 2m squared comes from. Similarly, when I pulled out the 4m from 12m squared n, I had a 3, an m, and an n left over. That's why I have 3mn. And for 20mn squared, I had a 5, and then n and n left over. So that's 5n squared. So that's where those remaining terms come in. Now I'm going to do my reverse distribution. That means I'm taking out that 4n from each term, putting it in front of a set of parentheses, and then we'll leave that 2m squared, the minus 3mn, and the plus 5n squared. Notice that I said minus and plus. It comes from those terms there. I didn't just make them up, I promise. They were what were originally in our polynomial. So you can see that it looks like this. And again, you will want to do a check where you redistribute kind of over on the side. When you do that in this case, you'll notice it gives you what we originally started with. So let's try another one. Notice in this case that it's negative 6a squared plus 36a. So when we're doing this, we're going to pretend like everything's positive just for the splitting up part, the prime factorization. So 6a squared, I'll do 2 times 3 times a, and 36a, I'll do 2 times 2 times 3 times 3 times a. And I can carry down my common factors, I multiply them together, and I get that my GCF is 6a. However, now that I am through that part, I'm going to go back to my original polynomial and I'm going to look at it. I'm going to notice that my leading coefficient was really a negative 6. So because my leading coefficient is negative, I will also include a negative in what I factor out. So instead of just doing 6a, I'm going to factor out negative 6a. So negative 6a squared, I can write as negative 6a times a. 36a, you'll notice I can do negative 6a times 6, but I have to include this negative. So it's really subtracting a negative to make it that positive. Now, when I pull my negative out, my negative 6a out, I'm going to be left with a minus 6 inside my parentheses. Again, easy enough to check, just distribute to see, do you get that original thing that you started with? And of course, you do. So hopefully that helps you kind of understand the basics of greatest common factors.